see if I can get the webcam going a little bit here. All right, so guys, I thought what I'd do is just show you, give you a little more perspective on the next few upcoming lectures. So I still have to update today's little topic here, but it's week 2, and this is lecture 2, or another way to look at it is lecture 5. Even though we didn't have a lecture 3, I'm just gonna number the lectures 1 through 15 since there's 15 meetings total. So this is lecture 5. Now I've got Swift sitting here, and maybe I'll just while we're looking at it give you a heads up, because when we first developed the course, Kent Swift, Lisa Swallow, and I sat down and decided, how are we going to, best present this. And the two things that the two main things that I really wanted to cover were the Lovins text, because it seems like Lovins really has a vision, a long-range vision. Like he's looking out to 2050 to see what energy is going to look like. I also wanted to cover this energy finance for engineers book, and we haven't cracked that one open yet, but it's I've got a few pages scanned on it, and we'll go through it. It really puts down in quantitative terms a lot of the things we've been talking about so far, and these are Kent Swift's lecture notes and quizzes. He's going to come in, and let me just verify here. It's either Friday or a week from Friday. And I thought what I'd also do, I'm going to just invite the Energy Tech students, because it's a really good lecture. He has really done his homework into energy finance across the country, sort of look to see how different states, because energy is state regulated, not federally regulated. At least the utilities are. Okay. Okay, so I think I've got him for Friday the 18th. So 9 days from now, Kent Swift is going to come in and give his lecture. And he's going to talk a little bit about that same problem that we mentioned on day 1. Would you rather have $1 today, or would you rather have $1 tomorrow? Everybody wants the $1 today. And then when you're faced with the decision, would I rather have $1 today or $1.10 tomorrow? Then it starts to get a little murkier, right? Every single person values time and money differently. So is that clear enough? Yeah. So he's going to give the whole thing on time value of money in quantitative terms. He's going to give a few problems on that. Maybe I'll hide these quiz solutions for now.
Oh, come on.
Sorry, you have to learn.
I'm thinking that'd be quick.
Okay, and then I don't know if we'll be able to dig these old ones up, but I think now that the stuff's going on YouTube, it'll just kind of be there for as long as YouTube is. Okay, so that's Swift, and then what I did on Monday, I covered the first couple chapters of Lovins, and you said they're out there on YouTube, and the video and audio came through okay?
Yeah, I was able to watch all 3 of them.
Okay, yeah. And it's just about a half hour each, and
What's the YouTube channel?
Just search for Energy, Missoula, and Layton.
oh yeah, let's check it out. I haven't really looked. Energy, Missoula,
Go to YouTube first.
Layton?
Yeah, I did that inside.
Oh, did you?
But that same thing.
Yeah, there's way too much up there. Go to
Okay.
YouTube.
Okay.
I just first went to YouTube.
Did you? All right. All right.
Narrow the search a bit.
That's right.
trying to see. We've done all solar panels from Missoula.
185 years, man, check it out. If I click here, do you think it'll take me to my other channels there? Maybe not.
Flake, making some juice there. Storing the batteries.
Oh, that's a little,
I've got 2 solar panels. Hi.
oh, there it is. 2 views. Yeah, so let's see, if I do this, I can just paste it in the course. Waylaid, you can see I was trying to get the proper spelling of the past tense of waylaid. Sounds like Gary Oram might have been, waylaid, come to you.
I wasn't aware that
I know, I forgot, I didn't mean to give you a hard time.
I tried to make it, but everything I said, he said, go this way, and then everything that I did went that way.
I've had a few of those. Okay. I'll just put Lovins, chapter 1 and 2. There we go.
So that quiz that's up there,
Yeah,
I never took it.
no problem.
I can take it now.
Yeah, take it now.
I thought it was this week.
It's okay. No, I mean, that's kind of the, I mean, there's 2 other people signed up for the course, and maybe by some miracle, Reeve and I think Michael will actually appear and take it too. Maybe
Reeve
they,
wasn't gonna do, Reeve wasn't-
not Reeve, I'm sorry, Micah Nelson. He's been in a couple courses.
He was gonna be in Crampton and stuff, but he got some.
He usually gets busy, yeah, what?
Some kind of landscaping job.
Oh, he did, okay. Usually he's busy hang gliding.
Yeah, jumping off things.
So, yeah, let's see here.
I did get the book though,
You got the Lovins book?
yeah.
Okay.
I'm
It's
through chapter 3.
It's a hefty,
Great book.
it's a hefty book. I mean, those guys dumped a lot of brain power in there.
Yeah.
I don't think they're wrong. I mean, I think,
My
well,
question is, I guess we can wait for later until you get this done, but my big question is if you don't use the electricity, like, say, he's talking in buildings in chapter 3,
Yeah.
all about, we saved 68%, the Empire State Building.
Yeah.
There's a whole bunch of buildings, I mean, Illinois has got these new buildings, there's a bunch of, I can't remember right off the top.
sure.
But if that energy doesn't get used, is the power plant still creating that energy, and is it getting dumped somewhere in the waste? Like a dump load somewhere?
That's a good question. Occasionally,
Because, I mean, it's kind of do 10 if you do and 20 if you don't,
yeah.
Because 10 if you do, at least that energy's going somewhere to a useful place, and if it's going just to a dump load and being evacuated out into free space, because I was thinking, another point on what you is why we can't sell the energy back to the grid. And I was thinking that's more along the lines of, well, I paid for all this copper, are you gonna pay for all the lines to come out of your place? And then maybe that would work, but then again, I thought, they've always got these engineers sitting there regulating the output power. Because if they send in too much power out, they're gonna burn a bunch of stuff out. If it's not getting used, it's just gonna sit there, capacitors and transformers and just blow up.
Yeah.
So that's another problem, if I'm sending a whole bunch of power this way and they're sending a whole bunch of power this way, they can't regulate.
It becomes more difficult, yeah. And I think that's why we're starting to see movement toward the smart grid. I mean, the smart grid is one where it's trying to make some predictions. So it's taking data, right now, and
Kind of like Reed's little set up in the trailer with the little digital readout and tells you the charge level of the batteries.
Yeah, so there's a couple ideas there. So I'm just, smart grid, dump load, and then electrical to thermal.
I wonder that same thing too, like if we drastically reduce demand, are they really gonna generate less energy, you know? But they are trying to match supply and demand, so theoretically, if there's less demand, there's less generation.
Yeah, so, yeah, and I think it should come down to allowing the markets to be competitive, because if they are competitive, and say I'm a Northwestern Energy competitor, and they don't know how to shut down their coal-fired power plants when the sun is shining, and I do know how to store and regulate my renewable energy, then theoretically I should win, right? I should be able to draw a greater customer base, bring in more money, and the dumb grid, the coal-fired power plant that doesn't know how to shut it down, should lose. So, yeah, another thing, and you guys understand this whole concept of thermal energy, and that all of our energy ultimately becomes thermal. So you're saying, going off into space. I mean, literally that is where the energy ends up going. Whether it's actually used, right here in my laptop or in this LCD projector, I mean, it is just becoming thermal. There's nothing.
But that's being used for some purpose.
Right.
As opposed to just going off into space.
Right. Yeah, so you'd like to soak up all the use possible before it heads off into space. Yeah, for sure.
At least converts most of it. I think that's just the basic principle of the old incandescence, right? It's got to heat it up to get the light, and then once the heat turns into light, it just kind of radiates out.
Yeah.
Energy radiation.
Yeah, absolutely. And the incandescence, I mean, shoot, they're 150-year-old technology, and it was a result of Thomas Edison experimenting with air. What was it? Several thousand different materials I think he experimented with, and it just happens that tungsten has, its electronic orbitals are such that when an electron gets literally pushed through a tungsten atom, the electrons that are sitting there in the atom get pushed out of the way. Well, where do they go? They don't leave the atom entirely. They go to a higher shell, one of these D's or F's shells, and then when that electron eventually leaves, leaving room for that other shell electron to come back down, that's when the photon comes off, because the electrons coming in push them sort of up. You can think of it like up onto a higher shelf. It's giving it that higher energy. You're putting it on the top shelf of your fridge and your cabinets, and then it washes away. They come back down. Well, that energy has to go somewhere. Where's it go? It goes into a photon flying off. But we're better at that now. We use semiconductors rather than conductors, rather than like the tungsten. And the semiconductors, the distance between the shelves is much shorter. So there's not as much waste pushing those electrons up into the higher orbitals. But here, so smart grid, information and energy. And there's another thing I want to put out there too is I'll say information versus energy, and I want to say electronics versus electrical. And there's a big distinction there. So typically, when we think of, and I actually am going to go somewhere with this whole information thing, but yeah, and I think we can put them. I think we can put them in a little grid actually. So if we do this, I'm just going to insert a little table, 3 by 3. So, okay, so in this information versus energy thing, the information goes here, and energy goes here. And in the electronics, whoops, here I mean, and electronics, does that make sense? From a smart grid standpoint, if you have, so think of your own organism, right? You've got your brain, which is your intelligence, and then you've got your body, your muscles, which is your power. And you can think of the grid in a similar way. So the information is the computer, the control system, et cetera, and the power is the actual, well, maybe it's better to say electricity. Electricity. Where, and the same thing, electronics is the control circuit that carries the information, and that's not really the best. It's not really the best analogy. But one thing that we're starting to do here with our Department of Labor grant is actually roll out a electrician's helper. And a lot of people don't understand the difference between electronics and electricity. But this is basically what it is. The electronics is your intelligence, your computer, your chips, and the electrical is the transformers, the cables, the wires, the grid, all that. So is that making sense? Let me just, this is more science. This is kind of technology. Right? Science / physics. And this is more technology. Okay. So, I don't know if that answers your question at all, but the idea is the smarter we get with our computers, the less wasteful we should become. You know, it's the same thing with your, with your GPS system in your car. It kind of makes your car smarter, so you're not driving around wasting energy. You know, you put a little brain in your car, so you know where to go. You're not driving around forever. Okay, so that's that. Let me kill this file. Don't need this. That's fine. Don't need that. Okay, so Swift is coming a week from Friday, and then this gal by the name of Kyla Mackey. She's coming on the 14th, so Monday she'll be here, and I always kind of thought she worked with Montana DEQ, and maybe the Montana Environmental Information Center is a subset of that, but she's been working for quite some time to do a financial analysis on clean energy in Montana. So here's what she's got. He says, I'd be happy to cover the jobs report. So she had a guy out, gosh, I think he's, from Cambridge, Mass, who has sort of done this at a federal level. And he's got like dollars per megawatt hour and levelized cost of renewables compared with fossil fuels. So what she's really tried to do is say, how many dollars worth of renewable energy does Montana have? And it turns out it's huge. first of all, with all the real estate, all the wind, all the sun, and what she ends up, I think what they've done, I'm gonna sort of press her for this a little bit, but I think what they've done is said, okay, now we're gonna install some renewable energy systems. How much does it cost up front? How much does it cost to maintain? And how does that compete with fossil fuels? It's actually pretty impressive news. It's not, I hadn't really, wow, that's a lot of potential jobs, especially if you can make it cheaper than what the fossil fuel industry is been able to come up with. So that's Monday. Okay.
Should turn your gamma and your brightness back up on your camera.
Oh, did I mess with that?
Just
What's the gamma do anyway? Seems to be kind of brightness. Does it mess with the ratio of colors somehow, or?
it'll pixelate it a bit, but if you pull your contrast back down,
Down? Probably, oh, you know what, probably looks different on my screen than the... Go with that nice green.
you want the brightness.
Yeah, I guess you're right, yeah. It's got to compete with the lights.
It's gonna pixelate a bit.
Yeah.
What's the backlight do? I haven't,
I think it's supposed to put more contrast between whatever's in the middle of the
halfway
screen.
looked okay about halfway.
It's like a
Maybe we should get you
one
a
to
set
it.
of studio lights instead of.
That's not too bad. Okay, so let's see here. So we talked about Lovins a little bit. The quiz is sitting there ready for you to take. Did you say you take it already?
Yeah.
Okay. A lot of it's just like, did you read the book or not?
Yeah.
And then let's look at this Nash thing a little bit more together. And so what I thought we could do, guys, is, and I don't know if this is too much for the EPA or not, but I think it gets back to some of Adam's learning goals when we were talking about how people value, value the environment, value money, et cetera. And so what I kind of wanted to do is play around with building our own Nash matrix. So let's look at the Nash paper. And there's a fair amount of, none of it's really much more than algebra. You can see that these are probabilities that he's dealing with, and so they're always positive. They're always between 0 and 1. And what he's also showing is that if
What's the comment in that mean?
the comment, it's a set of probabilities. So the first one is going to be one person's set of outcomes, and the second one is the other person's set of outcomes. So you can almost think about, well, in fact, you can think about it like a XY coordinate system. You can think of this one as X, and you can think of this one as Y. And so if you come back down to his figure, he hasn't labeled them as such, but you can think of this as the X-axis and this is the Y-axis. So that's what it is. It's that function. And if there were more players, and in fact, as soon as you get into the P3, there's 3 players. You kind of have an X, Y, and Z, don't you? But let's just look at this outcome a little bit. So here's the classic problem is Bill happens to have these 1, 2, 3, 4, 5 things. Jack happens to have these 4. And so what Nash has done is set up this little matrix and said, well, just because Bill owns them doesn't necessarily mean he wants them. You know, just because there's a big pile of aluminum cans in my garage doesn't necessarily mean I want them, or the rest of my family wants to look at them. So the number, I guess for ease, and you could see making these numbers negative, but just for the ease of mathematics, he makes them all positive. The total number doesn't matter. I mean, it looks like he's sort of put this on a scale of 1 to 10, or perhaps 0 to 10. But you could just as easily go 0 to 1. There's nothing magic about the number 10 here, right? But what he's done is plot the various outcomes. Let me zoom in a little bit here. Can you guys read that okay on the axes? This farthest number out here is 25, and this is basically Bill moving left to right. So at a 22 is where Bill comes out the big winner, right? So he's the farthest to the right. But when Bill's at 22, poor Jack here is at negative 10. Is that clear? And I'll show you where that came from. Because right now, these are the things that Bill has. If Bill gets all of Jack's things, so if Bill gets Jack's pen, he's got an extra 10 in the bank. If he gets the toy, he's got an extra 4, the knife, a 6, the hat, a 2. These 4 numbers add up to 22. So Bill wins, and that's why it bumps it out here to 22. See that? Okay, now why does Bill's gain of 22 only mean Jack's loss of 10? Well, let's come back up to the table.
Bill's items aren't worth near as much.
Well, as it turns out, Jack's items are worth more to Bill than they are to Jack. Because Jack doesn't really want the pen that bad. Doesn't really need the toy, knife, big deal, and the hat, so also. So there's, so he's lost 1, 2, 3, he's lost 6. So that
Basic economics.
should be a negative 6. Yeah, it is, and this guy won the Nobel Prize in economics for writing the fundamentals of economics. But it hadn't been written out this way until 1950. I mean, we kind of take it for granted. Now, here's what, so this number, sorry, I think I misspoke there. I think I said negative 10. This point down here, and sorry, that little...
No, you're right, it'd be negative 10 if you looked at the numbers. I can understand the numbers better now that I know what the numbers are.
Well, it's not. It's negative 6. He did not label. He did not label the vertical axis past 0, but it should be pretty clear that this point right here that I'm cursoring right and left on, this point is higher than this one is low.
So he didn't get all of his stuff though.
He did.
He just got a pen, a toy, and a knife, and there was what else was up there that he didn't get? Because he had 4 things.
Oh, that's at the solution point. What I'm looking at is this point right down here. And this point down here is where Bill gets all of Jack's things, and he goes up by 22. Jack loses all of his, and he goes down by 6. Does that make sense? So, I'm wondering, could we do the same analysis for our P3 grant? I think it would it would give it it would give it more teeth than it had otherwise.
I mean, like, as applied to a specific.
Technology. Like, we were talking about making our own little yard lights, connecting them in series as sort of a solar starter kit, and, allowing, a homeowner to start their own little independent smart grid, if you will. Low voltage solar. So let's just look at it.
Yeah, I think we could.
Yeah,
Just depends what the variables are,
yeah, we have to choose them pretty carefully, because otherwise it's just going to get out of hand. But let's try this. Insert table. I'm going to just make it 4x4 for now. And I think what we have to do is let's look at it this way. People, planet, and what do we want to call our little? We can change the name, but solar gardening or
Solar harvesting.
solar harvesting.
Solar harvesting.
We'll just throw a few names out there. I like solar garden. We'll have our panel decide at the end. We'll have our marketing experts decide at the end here. I like the phone line idea too. Phone line.
Solar night.
Solar night. K-N-I.
Look at that, how do you get solar at nighttime?
What about solar night?
No, not at night, like, I guess it might work.
Yeah.
Solar night, because you could have like a, kind of a two for one there,
Yeah.
catchphrase.
Yeah. Okay, now what we have to do is, Kinnick. What we have to do is compare our product to, what's the alternative? Dumb grid, utility bill,
Maybe waste, too strong a word.
I don't mind waste. I could also say,
That's going to require a study of going into a house and taking the one house and saying, okay, this, or even electronics, okay, this electronics, we're sending 110 to it, it's only using this much.
Sure.
Okay.
I think that's out there. In fact, did you guys see the George Horvath lecture at all? I had a Northwestern Energy engineer come through, and they're just wrapping up a smart grid study. They did a couple little test houses, one in Helena, one in Georgetown? Phillipsburg. Phillipsburg, yeah. So maybe what we do is, 'cause you're absolutely right. We could contact George Horvath for smart grid data. And he might be willing to share it with us. And that would give us another reference in our paper. It would tie us in with, the guys that are actually doing the stuff, in industry.
I just looked at my kilowatt meter this morning.
What do you have it plugged into?
I haven't plugged in anything, it's in my drawer.
Oh, okay. You just took it out to make sure it was still there?
No, I was looking for my checkbook.
Oh, okay.
I looked all over for my checkbook,
Oh.
and like 10 minutes ago, it came to me, ba-ba.
There it was,
I was,
hiding under the kilowatt meter.
now I think it's in the little pocket of my travel bag.
Oh.
I took it because I thought that I might need it. I was gonna go over to the bank, because that's the last time I seen it.
Yeah, I've been leaving stuff too, man. I left my bag at the dentist and couldn't find my phone for a few days.
Back at the dentist.
My whole computer!
Oh, computer, boy, you was doped up on Dramamine.
Well, it was my son's appointment.
You weren't, you were getting the off gas the nitrous, huh? He was venting it into your enclosure.
I think I subconsciously, I wanted to get on my bike again so I could go across town and then hit Martini Mondays at the James Bar. Drop my little engineering card. You got to network, that's, remember
Shaken, not stirred, Martini Mondays?
no, I do the,
Double number?
I do the Manhattans there, yeah. Gotta love the alcohol reference right on
A
the
lot of
YouTube.
people show up to that Monday.
Yeah, and what it is, there's, they do, and I think different people have a tradition of going, but it's not unlike this little Hellgate Ventures, or what do you call it? You didn't call it Hellgate Ventures, Hellgate Venture Partnership, whatever Paul called his little Thursday get-together. And shoot, I bumped into some people that I know that might need some engineering services. And it goes all the way back to that first lecture we talked about of
Social capital.
well, no, I wasn't thinking social capital. I was thinking of like how much planning you can do for your economic future versus how much of it's just kind of random. Oh, I bumped into Bill Gates and he gave me a job, or just something completely random that you wouldn't have expected. But definitely networking. Okay.
You like my shoes.
You like my shoes?
You like my shoes. You like my shoes.
So I think what we can do here is start to rank these a little bit. Now, the issue I'm going to see right away is there's not one kind of people. There's not one kind of prosperity necessarily. There is only one planet, and I'm not sure that we're expert enough to say what the best thing for the planet is, but we have to put these in something that we can measure. So, and what I want to do is, compare, compare these two different technologies. So,
Can I just,
what?
before we start?
Yeah, for sure.
Can we lose the word dumb on dumb grid? I mean, I know it's kind of dumb, but people look at that and say, how dumb is it that I can go turn my light switch on?
Conventional grid.
How about business as usual?
Okay.
'Cause that's kind
I
of.
want to call it something grid, though.
Well, yeah, somebody business as usual grid. BSU grid.
Yes, I think this whole thing can just be called business as usual. Business as usual, conventional grid, utility bill, waste, lack of control. Okay, so on the prosperity side, this first one should be pretty easy to do, right? Because you're paying whatever it is per kilowatt hour. 6 cents, 7 cents. Do you guys know?
I think when you put in all the fees and charges, it's like 11 or 12.
Is it that high?
Depends how you measure,
Right.
Yeah, the base rate's like 6 cents, and then fees and charges pump it up to 11 or 12.
Okay.
Do we want to localize it?
Well, I think we should for now. When Swift comes in, he'll show you like a picture of the whole country and like how Montana does it, Illinois, et cetera, et cetera. So if we just localize it for now, we could then just take the numbers and plug in someone else's numbers for a different state, right? And we could see, oh gosh, this is going to make a lot more sense in California than it does in Montana, perhaps. And that's where our market needs to be. Or shoot, Beijing, wherever, you know, it could end up being our target market is in South America. Okay, so we can quantify this pretty easily, I think.
I didn't know that gold didn't conduct the magnetivity until just the other day. I've never played with it, you can't see the magnet to gold.
Oh, yeah. It's, nah, ferrous. I think there might be a couple of it, but the iron atom, just the way the atoms line up and the electrons are shared allows them to stay polar. Yeah, not with gold. Where the heck? How do I center this thing top to bottom? I thought I could just click in the table properties.
Oh, you mean,
I just want to.
little,
I just want to center it top to bottom too. Table properties, row, column, cell. Here we go. Okay, so 11 cents per kilowatt hour is where we can go. Now, what we have to show here in our prosperity is that it's going to be less somehow, right? I mean, otherwise, why would you do it? I think, because I think what we could do is build our own little Nash chart. So let's for now just kind of start with that assumption that we're going to have to be less. Do that, do that, do that, cell, center, okay. Less than 11 cents. And then here, I think we can quantify it. Probably the easiest way to quantify it is just carbon per kilowatt hour, right? Is that, you can come up with something else.
Impact? Because you also have like 90
Okay.
other non-emissions related issues.
What else? I like that, yeah. Mining impact. You can put CO2, you could do just about any effluent. You could do SO2, particulates.
well, here's a list of, that Lovins has listed out for do's and don'ts, what you ask for. And then what you said, we have to go less than 11 kilowatt hours.
Sure. What's he say?
He's, do not ask for a list of measures that pay back within 3 years. Do not ask for an energy model that will predict energy use. Don't ask for a wind turbine or a rooftop PV system. Do ask for, okay, so it's ask for a package of energy efficiency gains that will maximize net present value over a decade or more.
Okay.
It'll probably make, this is buildings though, for buildings more valuable. Do ask for a long-term schedule of major renovations so you can right time and right size them all. Do ask for other benefits that propose bundle of energy savings may provide like daylight, quiet thermal stability and control of air quality. Do ask for implementation advice and ways to engage your operating staff and employees to leverage the behavioral upside for energy consciousness. And do ask how you can clearly communicate your plan and track your progress to your senior manager. Make progress visible to employees and enlist their knowledge. That's for buildings, but
Yeah.
I was just thinking we could.
It's similar though, I mean, we're looking at residents. I don't think he has a chapter on residents. He does have, and this is what only recently became clear to me, because he's got I just call it BITE, for buildings, industry, transportation, electricity. And if you look, the electricity is a subset of buildings. So that's kind of the sector we're looking at here, isn't it? So I'll just do that, BITE, and we're mainly the electricity part. That's the bite out of bite we're trying to take. Okay, so I think what we need to do is compare apples and apples. So maybe we can quantify each one of these. So one thing you just mentioned there was decade payback. That's, it's a prosperity thing, but I'm wondering if it's also a people thing.
I'm thinking that's buildings over time. I'm thinking, and that's commercial.
Yeah, it is.
I'm gonna go with a person. I want that dollar today.
Mm-hmm.
I mean, how much is this gonna save me today?
Mm-hmm.
So what is your energy use on a daily basis? Say we can use the port bath, what's the daily basis of business as usual house? What's that energy? What is the perspective, daily basis energy usage of this?
Mhm.
How much is that gonna save me today?
Yeah.
Because I don't really care about tomorrow.
Yeah.
I might wake up tomorrow and the world might be struck. As long as I can turn my light switch on.
Yeah. So maybe, here's another thing, and I mentioned that Swift is coming in, Kyla Mackey's coming in. Now, B.D. Erickson, you mentioned, like, I want it today. B.D. Erickson, who lives here in town, owns SADC, just a very unique individual. It's hard to completely describe B.D. Erickson. I'll let him do his own thing. I want to have him come in, but he's also promised to have this buddy of his who, I guess, owns one of the largest PV companies in the country. And what they're trying to do is exactly what you just said, is to say, here's your free photovoltaic system, Mr. and Mrs. Smith. We're going to put it on your roof today, and here are going to be your energy costs for the next 10 years, or however many years. I see you've got a 30-year mortgage, you're 5 years in, you got another 25, so these are your projected costs. And so they build the customer's payback into, so the electric company is willing to say, I'll give you your dollar today, as long as you promise to give it back to me later. And that's the whole basis.
That's the basis of the company that you were talking about that's going to come in and install your PVs for free.
Yeah, exactly. Because they've already got the dollar today. They're the big guy with all the dollars right now, and so they're willing to invest in the future and see this payback. So
that was another thing that I was thinking when he was explaining that Levin's talks, how he used New Orleans as a basis, because he says most of the houses down there are leaky and condensation, humidity,
Yeah.
heat comes in and out, just kind of travels through them. But most of them aren't private residentials. They aren't owned by the people who live in them, so they're rentals.
Oh.
So it doesn't give the property owners an incentive to go in there and make the structure like passive house.
because they're getting their money from the
Because
renter.
they're getting their money from the renter, no matter. And if they
Mhm.
put money into that, they're just gonna keep getting the same money back.
Right.
So, it would be for them to make it useful for them, they'd have to raise rent at some point.
Right. Yeah, that's a really good one, because you got to wonder.
But now.
Yeah, I was just gonna say, you got to wonder if if they were to invest, they might actually keep their renters longer. They might not get as much money because they're not paying the utility. But I think the utility is just kind of a pass-through. It's not like the property owner is making money off the fact that the renter has to pay the utility fee, do they? Because they're just shoving it right back out.
Usually a renter, I mean, he'll come in, the guy will say, okay, this is the rent. You pay me the rent, you can live here. Okay, so the renter's got the problem, the utility, the gas, the sewer, the water.
Typically on top of the,
Typically
yeah.
on top of all of that.
Mm-hmm.
Some places aren't like that, utilities are included. Now,
Yeah.
Those places, you would save on those, if
Mhm,
utilities are
mhm.
included, but most places don't do that. So the guy that's getting the rent, that steady income, like it's like somebody drawing Social Security, you know? If inflation goes up and the price of everything rise, that Social Security ain't worth as much.
Mm-hmm.
So the guy that's renting this house, basically, if he puts money into this house that he's renting, sure, it may and it may not rent longer. It just depends on where it's at in the residential neighborhood, which is another thing on the house
Mhm, mhm.
for the pricing costs. You can have $1 million home, if you put it down in the ghetto in Los Angeles, nobody's gonna pay $1 million
Mhm.
because they don't know what to buy on gang violence.
Mhm, mhm.
But back to the New Orleans thing, if the renter's paying, say, $500 a month on rent.
Yep.
If the property owner goes in there, makes it so that the renter doesn't have to pay $80 for electricity a month, he only has to pay $50.
Sure.
The guy's not getting any returns, the guy that owns the house. So it doesn't really matter much.
Yeah.
Attracting more renters, though.
You might,
You don't think so?
You know, it won't attract more renters to say, okay, this is a passive house. Now, if he's got a big property and the name is subsidized somewhere, and then, okay, this is a passive house, you know, you'll save on electricity in this house, it may give you more renters.
Yeah.
He's still gonna have to be able to say, you know, I'm gonna have to put R value windows in there. I'm gonna have to put, you know, triple pane glass, some, you know, even the glass that reads the heat to let stuff go in and out.
Mhm.
He's not gonna get that return on that house ever, and if he doesn't get the return, I mean, why am I putting money into this place? He's gonna come pay $500 for it, no matter what.
Yeah.
And one of the big, sites that I can pull off is right here, down by University Drive down here.
Yeah.
Right in front of the college.
Yeah.
It don't matter what those houses are, I mean, sure, some of them are big and huge and they look pretty, but, you know, you take that same house and put it on the other side of town, nobody's gonna pay the same price.
Oh, yeah, sure. Yeah, yeah.
Because it's just location.
Yeah, it's a real estate question. Okay, so with this guy, let's just kind of throw these out as questions. You know, could you do what is the payback timeframe? What is the installation? So, and then this one, business as usual. There's really there's no payback. There's no such thing as payback.
Well, not,
Because you've,
to the grid owners, there's some sort of payback.
yeah, so I think this people equals consumer, right? That's why I said it's gonna get a little tricky, like, which people are we talking about, on the receiving end or the supplying end? I think we have to look at it from the consumer's point. There's a lot more consumers than there are suppliers. There's only one Northwestern Energy, but there's several million customers. So there's no such thing as payback. Now, the free install, this is already installed, basically, right? Just your,
How do those guys recover their investment or make money off of giving solar? Do they have a deal with utility?
are you talking about B.D. Erickson's pal here?
Yeah, sorry.
I don't know. That's why I want to have him come and talk to us.
I'm curious.
But my inkling would be that the owner has entered a power purchase agreement with the utility, and basically says, okay, Northwestern Energy, I know where you're buying your electricity from. You're buying it from the dam over here, you're buying it from the coal-fired power plant over here, you're buying it from the nuclear plant over here, some comes with, like, he knows where all those primary energies are. And he says, listen, I'm going to be another primary energy source for you. What is it? Well, it's 10 megawatts worth of PV I'm about to pop onto your grid here in the next 10 years. And And you're going to buy that from me, because I see what you're paying for all these other ones already. And you're going to buy it from me at this particular cost, because, I can't imagine, I
That's the
mean,
decade thing.
yeah, that's the decade thing, yeah. Because, and that financial institution isn't a place to do that, I mean, these are financial institutions that have been in business since there was money. You'd think, right? I mean, these people that have done a good job keeping their money, and so they've thought about this very carefully. And so they're just adding themselves as one more little middleman, and they might, I don't know, from there, I don't know where it goes. I don't know if it's the money flows from the consumer to Northwestern Energy back to the installer. You'd think that's where it would go, rather than from the consumer to the installer to the energy company. I mean, so that's what we can ask this guy when he comes, if he's willing to divulge his secrets.
Right.
And I got to say, I don't know, I had this kind of long, drawn-out conversation with my wife the other night about, like, dishonesty and money, but let's just take a break, and then I'll tell you more about it. Just under an hour there.